Good morning. So I'm going to explore GIS methods for reconstructing boundaries based on historical data, which are always nice to test your methods with. To start with, there are two sorts of boundaries that are described in the literature. One sort is the borderlines, the other sort is fuzzy transition zones, and of course natural linear boundaries are often very prominent, but in many parts there are non-natural boundaries, and there are markers which can be found in the archaeological record. This is an overview of the talk. That are the methods that will be discussed in very shortly. And you see that Thiessen polygons play a role here, although they are not really liked nowadays. But we will see how far we get with them. So this is a study area, and we start with a very easy application of GIS. We have this linguistic boundary, which I just took from Wikipedia and put it in my data set, and the data set consists of 1165 settlements mentioned before 1600 AD. And you probably will not know the area, but you see Waldbröl down there, and this is a famous place where Axel Posluszny, the former president of CAA, went to school. So, to continue with the linguistic boundary, this is here, and there are F words and there are P words left and right of northeast and southwest of the boundary. And there's one misclassification. I have to go into this one. So even with this small query and GIS, you might detect a boundary. But this is just to warm up. And another warm up is the normal Thiessen polygon with Euclidean distance based on a text list from 1308. As I mentioned before, these Thiessen polygons have been heavily criticized because nobody walked like this. But the idea is that wherever you are, you have to attend church on Sunday with this example, and you take the closest church or chapel. So you can refine this method, of course, and take the least time-consuming route. What normally is done with least cost analysis is you take slope and you take maybe the rivers or other water courses into account, and that's what I did as well. These are the weights attributed to each of the cost components, and I just took Tobler's time estimation function. I could have taken other ones, but I thought maybe attending church is walking more than going by vehicles. So what I did now is to compare the areas, and to my surprise, they were not that different between the Euclidean distance and the least cost distances. But pedestrian walking is not as bad as vehicles in terms of least cost differences to Euclidean distances. So then I tweaked it a little bit more and said, this is a text list I have, is the churches, and so I can compare the territories computed by Thiessen polygons to the taxes per square kilometer. And you see that there are some differences, and the differences in part can be attributed to differences in soil quality. So there seems to be something into in Thiessen polygon calculation. But what we also can do is comparing Thiessen polygons to the modern boundaries. So in this case, we have 25% overlap, which is not really nice, but it's too much to say that it is just arbitrary. So there is some relationship between modern boundaries and these cost polygon borders. But there are still some experiments to be done here. For example, looking at the churches which are no longer the main spot today. So the parishes parish names changed in some parts, and I think the continuity is better where the parish name is the church name on this map. So to proceed, as I said, I like to work with historical data, and this is a very nice map from 1575. And this was created in the course of a dispute concerning the boundary. And there is another map, which I don't show, which is not as nice, from 1608 or 7, which shows the final state of the boundaries. And here you have I digitized the boundaries and transferred them to the modern map, and then I digitized whatever I could get on the boundaries, and some of them coincide, some don't, and so then I started to work with it again with Thiessen polygons first, and Thiessen polygons in this case, they don't work out very well in my view. Neither straight line nor least cost. But I came to think of, and I read a lot about it, that the churches might not be the main things in this part. Maybe administration units are the main parts. Or judicial responsibility, or even the linguistic parts might play a more important role than the churches. So what you have is a kind of web of different hierarchies or central places, and this I wasn't really aware of before. So in speaking of medieval times, I don't know how this looked in Bronze Age. So there is a lot of boundary continuity in this part, and often the boundaries coincide with old paths. And those who know me know why I came to this studies. So one other approach I took is looking at site catchments and comparing the site catchment for a castle, which is very central and important in this area with the boundaries. And there, well, it doesn't coincide very well, although I put a green arrow there. But these site catchments gave me the idea that you have the decreasing influence zone. So close to the house, you work more, you are more close to the house, and in the garden you're less, and so on. And this really it gets you into kernel density estimation, because this is modeled by kernel density estimation, and you have the normal straight line kernel density estimation, and you also can adjust this to least cost kernel density estimation. And that's what I did. And this is just a small overview of least cost of kernel density estimation, which has been in archaeology for a long time. And when you apply least cost density estimation, you can easily recognize empty areas if you apply this for the settlements. There is an empty area here, for example, if you apply this least cost kernel density estimation for a grid of locations, then this results in accessibility maps, and the accessibility maps really were the things I liked best for boundary reconstruction. As you see here, the boundaries, the historical boundaries, are mostly found in high accessibility areas, and some are found in very low accessibility areas, i.e. they coincide with rivers. So there seem to be mainly these natural boundaries, which are either high accessibility or rivers. This is my conclusions. And in my abstract, I had promised to provide a combined approach, and I was thinking of creating least cost Thiessen polygons with high costs attributed to boundary candidates, and then to spread out with this. But I found that the central places mostly are not very central. The central places are found are mostly not found close to the in the center of the boundaries that I have here, and therefore I think this doesn't work. So this is work in progress, and maybe I get some nicer ideas from you, for example.